Okay.
Oh,
The whiskey
so
across.
things will slow down for me. So
Yeah.
it's nice that they tell me.
Okay. Do you want to?
I think we have another minute. Oh. All right. I guess we will start. Welcome to 6-Man. This is the first of 2 6-Man sessions today, and we will have a break so you can go to internet area in between. And I hope you appreciate we arranged for a room with that's not freezing. So who knows, it may get too hot, but we'll see. Okay, next. Yes, there we go. And I hope you appreciate Oli's slide here. So here's the note well. I'm sure you all have had this tattooed on your arm already. So we will all do this. We have a Jabber room. There is Meet Echo, Etherpad. Barbara is taking minutes, and Peng Shuping is the Jabber scribe. Thank you very much. We really appreciate that. We try really hard to get people lined up to do it before the meeting starts. There's all the presentations are all uploaded, and the blue sheets are being circulated. So for today's agenda, we have 3 working group drafts to discuss, or working group items: the fragmentation in RFC 8200, the PathM2 hop by hop option, the OAM segment routing draft, and then we have 3 individual drafts, active individual drafts being discussed. And then if we have time, we have 2 new individual drafts. These may, if we run over, these will get moved to the second session at the end. And then in the second session, we have 2 drafts relating to header insertion. And what we're would like to do for that, we'll talk about this at that beginning of the session, but have both of the speakers do their presentations. People should ask clarifying questions, and then we're going to try to have a discussion where both speakers are in the front of the room. This is the first time they're hearing this too. So we're hoping that will be a good, people can ask questions and they can both answer because they are interrelated. Okay.
Right. So then we're back onto document status. We have not published any RFCs since the last meeting. We have finally gotten the segment routing document into the RFC editor queue, so that should probably get a number very soon. I'm sure there are other SR documents in the pipeline, so we might not clap ourselves on the back too early. All right, yes, the IANA allocation for that document is done. So yes, run out and implement. The ICMP error document is submitted to the ISG. The IETF, the pref 64, the NAT 64 prefixes and router advertisements. That's in IETF last call. We have run through a few reviews on the privacy extensions for Slack document. That is not on the agenda for today, but I expect we will working group last call that very soon after this meeting. The minimum path MTU hop by hop option document is on the agenda. So is the OAM document for segment routing. So we'll talk about those afterwards. Yeah, so that's the document status. Any comments on those? Then I just wanted to remind you that the document process has changed. Here's the links to the both the format FAQ and the XML to RFC tool updates and the vocabulary. there's a neat tool to use to convert from V2 to V3. So I think, from now on, we expect documents to be V3 coming out of this working group. And also feel free to use the GitHub we have, so we can do pull requests for changes and don't have to discuss, small editorial changes, on the mailing list. It's a bit more efficient to use a modern tool for that, but that's up to people what they want to use. Okay, so I think that was it. I think, Bob, you are up. Here's the clicker. Please stand in the pink box.
Great. Thank you. Now you just saw all the slides. I can stop. So this is the next step in the errata, the fragmentation errata that was reported against RFC 8200. Just two background slides, the same as last time. 8200 included a number of updates in 4 RFCs. This required extensive changes to the fragmentation text in section 4.5, and subsequent to 8200 being published, a number of errata were filed. The general problem is that the fragment offset defined said it was pointing to the fragmentable part where it should have been pointing to extension and upper layer headers. Text needs to change in 4 places, the figures, and the proposals in the errata proposed other changes. As we have talked about, we've figured out, I think, a better way to address these errata than what was proposed in the errata. And then there was also 5173. And with what we're proposing to do, this is sort of not even an issue because this figure changes in a way that this isn't relevant anymore. So we've at the last IETF, we proposed the new text. It was discussed. This has been discussed on the mailing list, and I think there was general agreement on the changes, with one addition, changing subsection 4 from the first fragment to the remainder of the first fragment. You'll see this in a minute in context. So I think we're in good shape. So I'm going to do 2 things here. So this is, the HTML diff. So you can see on the left is the old and the right. I think it's a little hard to follow because, like in this one, there's a paragraph that looks like it's deleted, but it's actually moved later where it makes more sense. So I'm going to go through these you can see them and they're online very quickly, or you can run your own. Whoops. And, there's a lot of changes to the figures. There's a few, this is where that paragraph gets inserted, and then you can see the other number 4 change, the remainder of the first fragment, and then some other changes to the figures. So it's not a lot of changes, but they are important. So what I did was create my own diff for the presentation. And it's a lot of slides, but I think it's a clearer way to see what the changes are and also to see what's not changing. So many of these look just like this, where there is no change. The next one, or this one, there we go. So this is the change to this figure, where instead of showing extension and upper layer headers in the examples, it's now just talked about in the text. And the text says, as it always did, the first fragment includes the extensions and upper layer headers. So as opposed to trying to do it in the figures. And I think this makes this much clearer. And then you can see the paragraph that's getting moved later. And then this paragraph is rewritten. I think I did this correctly. And then there's another figure change, the same sort of thing, not putting extension and upper layer headers in the figure, just, they're just part of the first fragment. And same here. And this is where the that other paragraph goes, where it makes a lot of sense because it's the paragraph about extension headers, but the paragraph itself did not change. And then here's the remainder of the first fragment. And this page, this didn't change. And here's another example of the not calling out all this detail in the figures, which created other problems. And this didn't change, and this didn't change, and this didn't change. There's a lot of these, and the last one also didn't change. So the changes are, I think, are pretty focused around solving this problem. So the plan we worked out with Suresh, our area director, is to open a new errata that describes the errors in the fragmentation text, and include the revised text. And this will basically be a new section 4.5, a revised section 4.5, and then he will accept the errata with status of verified, saying it is a technical problem, and it is correct to fix it. And then the other 4 errata will be marked as rejected, and in the notes point to the new errata. And so this is the format of the new errata. And so erratas, when you file them, they say, you fill in what the current text is, and then you put the new text, and then you have a note which describes what you're doing. So, so this will have the current text, this will have the new text you've seen on the list and here, and then this will be the note. And it's, a short summary of the problem, and that this errata replaces these other errata, and the change has been reviewed here. And that was it. So any comments or questions?
So Bob and I have read through this text quite a few times, but I would really like a couple of reviewers to read through it from start to finish, and to ensure that we really get it right this time. I think we used up our quota for getting it wrong. Eric.
Eric Wenk, individual contributor here, obviously. On one of your slides, you showed the reassemble fragments. Can you come back on this one?
Which?
Yeah, come back. Yeah, on this one.
Yes.
Obviously, we need to remove the X and upper layer header, but I like somehow to keep the first frag data, second frag data, and last fragment. Matter of test.
Yeah,
I don't mind either.
So it also turns out that if you go back and look at 2460, what we're ending up here with looks a lot closer to what's in 2460, where it was described. So, there's 6 different ways of doing this.
Absolutely.
I mean, I'll go look at that again, but it seemed like I think what we discovered is trying to break this out into a lot of detail ended up causing some other issues. And the important thing is to read the text, which is, I think is correct in 8200, but the figures make this more complicated.
Okay, fair enough.
Yeah, I was the editor on this, and it was really hard. It was a challenge, and it went through the whole IETF, the 6-man and the IETF working group process, and the last call, and all of this. So it was not till much later that this was noticed that there was actually a problem with the text. But bringing all the changes in. We did a lot of things here, and getting text that is understandable and worked was clearly a challenge, but we all failed. Okay, so, Suresh, good.
Yeah, Suresh Krishnan. So, Bob, if you just send it, once we agree on this, let's put a timer on it, and then I'll verify it, let's say, end of the year.
Okay, or my question is, when should I file the new errata?
Put it in a timer on the list for people to comment on this way forward, and then probably in 2 weeks or so.
Okay. Will do. Thank you.
Yes, so we need at least a couple of people who read through this thing and give their thumbs up and can't find any other issues. If they can be bothered to implement it from this text, that would also be nice, but we don't quite expect that, I think. It's just a few hundred lines of C, right? The flight home. Okay, Bob, thank you. You stay up here, that's right.
Is Gory in the room? Good.
Can you fit 2 in a box? There's a two in a box.
Well, there's no box, it's just an X.
Oh, there's a...
Let's handle the corner of the X.
I'm Bob. This is Gory. This is just an update. I'll go through this quickly. Yeah, so you've heard this before. We know there are problems with PathMTU. This was sort of part of the idea of sending feedback from the destination instead of from the middle. This is the current format that's defined in the draft. This hasn't changed since the last IETF meeting. But, so since 105, this was adopted as a working group draft. First working group draft was published. We did a request for an early IANA allocation. This was assigned. We published a new draft with that and a bunch of text clarifications. I also had my Wireshark code for this accepted in Wireshark. I haven't done anything like this for a while, so it was learned a bunch of stuff in all dimensions, and I'm not sure which. I think it's going to be in the next distribution, but that it's in the developer's distribution. And I'll hand this over to you.
Me? Okay. Sure. Okay. So we've made some measurement experiments to try and measure whether we can send a hop-by-hop option or an extension header where IPv6 works, and where we find a bigger MTU supported, whether we can send a bigger packet, and where in the network it might not get to. So that's the general scope. We have some probes. We currently have 5 on this list here, and we have a few more to give out or run, maybe as virtual machines, if anyone would like to join us as a place to run these measurements from. So these measurement probes run using Ansible. They're remotely deployed. They remotely execute a script of experiments, and then they retrieve the data back to a central point with us. If you have a large MTU IPv6 supporting link, which could be a good audience to talk to, and you want to do this sort of experiment, talk to me and I'll explain in detail what it is. I'll talk at PanRG as well, and I'll mention a little bit more about our probes. It would be nice to say we've done experiments. It's kind of only just true, but at least in the experiments we've done, we've found of like 1/8 of the destinations we probed actually supported hop-by-hop options across the path we use, which is kind of fun. Now we got to check what that means. And there was one particular location where none of the packets went anywhere when they had a hop-by-hop section. Yeah, it's Bob's fault. Whoever Bob's ISP is, or somewhere along that path, something goes wrong. Obviously we're going to troubleshoot that. So there is definitely evidence that hop-by-hop options do not work across the internet. And there's definitely evidence that they can work across the internet in some cases. So there's the data point we're at. More information next time. This is the sort of question we're going to ask. Probably obvious now. How often is the path MTU smaller than normal? How often can you use a much larger MTU? Are IPv4 and IPv6 playing the same? Might not be interesting to 6-man, but sure is interesting to me to figure out what happens. And can hop-by-hop options be sent, and what's the pathology? We're going to try and look into pathology so we understand why as well as just what. Continuing experiments, please talk to us. Is that the end of our slide deck? Well, you can talk to us then. Does anybody want to talk to us now? Please form a line if you wish to help us in our measurements. Seriously, we're available on the list. We're available at the IETF. Just talk to us if you want to do that. But if you want to ask any questions, please come and ask.
Eric Klein question. Do your probes run on the RIPE Atlas framework?
No, we have ideas of collaborating and running these from RIPE Atlas positions as well. The reason they don't is because there's a restricted set of experiments you can do from RIPE Atlas positions, and that's one set of experiments from lots and lots of vantage points. Our probes were more intended to run from one vantage point and measure lots of different paths and lots of different ways through the network, and therefore we gather a different data set. These two data sets are needed together. So yes, that is interesting. If you want to actually just do more than ask the question, please talk to me or talk to someone else.
I just happen to have an Atlas probe at home, and I'm sure I know many people who do, but...
Excellent. Well, you should join the experiment. We'll find a way to enable you.
This is Robert from the RIPE NCC. I have been summoned. It's a solvable problem. Let's talk.
Cool.
Ooh, yes. That's great. Thank you. Right. We did good work. Good.
Hello, sir. One more question. Charlie from Huawei. May I ask a question that is this mechanism used for OEM packets or the data packet?
This is an IPv6 extension header.
Yes.
So what the packet carries, I don't really care. I mean, so do you understand more?
Well, the only thing I'd say, I mean, it can be in any packet, but it's really not intended to be in maximum MTU size packets. Right. But read the draft, please. It's all in the draft.
Yeah. Okay. Thank you.
Thank you.
Okay, super. I think if I remember correctly, we have Safar next. You have 50 minutes on. Are you doing both drafts, Safar, or just the one we have here? Yep, super.
Yeah. Thank you.
There's the clicker.
Hi, my name is Zafar. Can you hear me well? Good. So I'm going to present update on the O&M draft. It's got adopted on behalf of my co-authors. Here's a list of contributors to this draft. And here's a brief history. So the work started back in July 2017. We had 8 revisions. This document has been actively discussed and presented both in spring and 6MAN at different times. It got adopted at 6MAN. Thanks 6MAN to accept this. But there was a lot of time that the draft keep finding it home while the implementations were happening, and a lot of discussion and reviews happened, both actively on the list as well as off the list. And since adoption also, we have addressed all the comments received. Here's the summary of the draft. So the draft basically mention how we can use existing ICMP mechanism for O&M in SRv6 network. And then it also defines use of SRH flag. Specifically, it basically say it defines the O flag for O&M purposes. And then it also defines some use cases with how the O flag could be used. And it also defined 2 O&M sits, specifically n.op, which is a behavior designated for O&M endpoint with punt instruction, and n.otp, which is designed for O&M endpoint with timestamp and punt instruction. So that's the overall summary of the content. Since IETF 105, we did receive some comments on the draft. Specifically, there were some comments with respect to use and processing of O flag when a packet is received with SL equal to 0. This version addressed those comments. Thanks very much for your comments. But this addresses the comment, this version. And then there were also comments regarding some cases where there could be duplicate ICMP error messages sent, and then this draft does clarification for those as well. And then there was quite a bit of comment on editorial changes, and all those changes had been made in this version. So the main change, which is from a processing point of view other than the editorial thing, is regarding clarifying the O flag processing when a packet is received with SL equal to 0. Now, this does not, the change is still editorial in nature. From the get-go in July 2017, when the O flag was defined, it was defined to make a copy of the packet and with the timestamp and forward. So it always defined as punt, forward, and process the local SID. However, it was a good comment that is not so clear what happened with SR equals 0. So what we did is we specifically link it back to the SRH draft and basically say that the instruction really that goes at S01.1 is that if O flag is set and local configuration permits, then do make a copy of the packet, timestamp, and send that to local O&M process. Now, this obviously get executed before the SL check, SL equal to 0 check. So basically, this change clarified then the comment. Now, on the deployment status, at the moment there are 6 deployment running in a production network, running significant amount of commercial traffic. That includes SoftBank, China Telecom, Elite, China Unicom, ClearNet, and MTN Uganda. And there are some other deployments that are known but not publicly disclosed. For the public disclosure, there is a draft for the SRv6 deployment status, and these and the operator have contributed to addition of what they have deployed, and it is specifically mentioned that O&M has been deployed in these deployments. From an implementation status point of view, there are 12 hardware implementation of the draft which are shipping, and those are deployed as well, as we saw. And there are additional known implementation, and the details are provided in the SRv6 deployment status draft. For interoperability, there was a multi-vendor interop event in European Advanced Network Test Center, EANTC, back in March 2019. And the results for the interop has been discussed and disclosed as part of MPLS World Congress in April 2019. These are publicly available and are referenced in the SRv6 deployment and implementation status draft. From a next step point of view, since the draft has been deployed, there are at least 12 hardware implementation of the draft with shipping and interoperable code. We think that draft is stable, implementation exists, interop has been done, and we intend to do a last call for this draft. If depending on chairs, how they take it, but definitely by Vancouver or between now and Vancouver, but we will really like to hear more feedback from the working group, more reviews, and we will welcome any collaboration. Any questions?
So while people are running up to the microphone, so since this is a 6-man Spring document, when we will run a working group last call, it will certainly be last call in both working groups. So I found, unless you are quite versed in SR and Spring terminology, you might find this document a little hard to read. How many people have read this document in 6-man? Excellent. Yeah, so quite a few. So I would certainly encourage people to review it here with sort of your V6 or 6-man hat on, and give us feedback. We have, and I guess we should discuss this with our AD if there might be overlap with other working groups as well. There might be, I believe, IPPM, for example, works on sort of similar-ish issues. If we should get those in, them involved now, I don't know, Suresh, I see you nodding, but.
Suresh Krishnan. So I was not really thinking about the stuff that's generally covered by last call review. So I was thinking the other groups will get looped in later in the cycle. But I think the spring is probably important around the time of working group last call. So the other stuff after AD eval, I'll probably send some early review requests. That's kind of how we handle stuff like Gang and things like that. Do an early review request if possible.
Yeah.
But after the working group process.
Yeah.
That's kind of how I thought about it.
And this document depends on network programming, I believe. So it would be stuck behind in the queue for network programming document, right?
No, I think these are independent. It doesn't depend. It defines from the code point of view, the behavior, INR registry point of view and all, yes. But otherwise, from a technicality point of view, no.
I think ULA means it's a normative reference, so it's going to not get published. I think you understand the mechanics, right?
Yes.
Do you know, top of your head, where in the pipeline the network programming document is? We can.
So network programming last call request has made. Pablo is here. He may would like to add something, but my understanding is that last call request has been made, and I at this spring working group. Pablo.
Pablo Camarillo, Cisco. So yes, at this meeting we requested the working group last call, and we expect it to proceed soon.
Okay. Yeah. So we'll follow up on doing that. Probably after the network programming or close in parallel or in parallel. Yeah.
Because
I think it's fairly advanced as well.
Say again, sorry.
I think it's fairly advanced in the process as well.
Yeah.
So one thing that came up, kind of we talked about it, the 6-man related stuff, as well as they require a protocol number allocation now. So they're going to go with the early allocation request for the protocol number. So I don't think it's going to stop anything. It's just that bunch of process steps to be made.
Yeah. Okay. Yeah. Super. Let's get that going.
Thank you. And we'll appreciate really feedback from the working group. Thanks. Bye.
Okay, Jen, I think you're up. I think we have a 6-man document about this font choice of yours, but I can't remember the number at the time.
You should publish it. It's the 1st of April. Hello. Who has read the draft, or at least know what's about? Oh, come on. So who was in V6 Ops? Okay. We can count how many people were reading emails. So, quick recap then. The problem. Host joins the network, sends an RS, gets an array back. In that array, there is everything host needs to configure addresses, to know the default gateway, IP, and MAC address. Everything is ready to send the traffic. Good. By the way, router at that point has no knowledge about host global addresses yet. Now host starts sending traffic outside to some internet destinations. All good, but then return traffic coming back. And router again has no entries in neighbor cache for the host global address. So router, as per standard, buffers one packet and starts address resolution for the host, dropping all other packets on the floor. So as a result, only first packet might reach the host, everything else is dropped until host starts retransmitting. Apparently, some applications might be quite unhappy about that, which causing significant user visible delays in connecting to the network. You can see it yourself if you connect to V6 only, not 64 SSID here. Some of your phones might show 5-7 seconds delay caused by this. Because in ideal world, it would be nice that by the time the traffic coming back to the router to be delivered to the host, router ideally should know where to send it without all this additional delay caused by address resolution. Why we do not see it in dual stack networks? Because hosts send ARP packets telling routers about their addresses. Routers get their ARP cache updated, and because of happy eyeballs, nobody noticing anything until you turn off IPv4, and then you start seeing the problem. Why we cannot have the same nice thing in IPv6? Because a neighbor discovery RFC claims that if V6 device receives an unsolicited NA, and there is no entry yet for that address, then it should be silently discarded. And luckily, we have an explanation why it should be silently discarded, because there is no reason to create an entry, because the sender is not trying to talk to you. It's definitely true for host by host, host to host, but it's definitely not true for traffic sent through the router outside. In this case, yeah, host is not trying to talk to a router, but router will need to talk to host back quite soon. So there is a draft in V6 ops which explains the problem and enumerates possible things we can do to solve it. And because some of those solutions involves updates to neighbor discovery state machine, I was advised to come here. So here we are. So the draft, which is in 6MAN, was sent to mailing list some time ago, propose some solutions, discuss the potential disruption, which might or might not be caused by the solution, and has some security considerations. So what we want from the solution? We definitely need to be able for the host to create a stale or incomplete entry in router neighbor cache when a host starts sending traffic. It should not cause any disruption in case of duplicate addresses, for example, if there is an existing entry already. And it would be really nice if it would work for optimistic addresses too, because the whole idea of optimistic addresses where I want to send traffic as fast as possible, as soon as I get array. And also, if I have multiple first hop routers, it would be really nice if it would work for both of them, because host might send traffic through router 1, but return traffic might come through completely different host router. So what we can do? We can do nothing and claim it works as intended. Transport protocol should take care of all of this, and packet loss is okay. I kind of disagree. We can do what we do for IPv4. Hosts advertise their addresses in unsolicited NAs, routers update caches, everyone is happy. We can let routers glean from that packet. Also a solution, as far as I know, a few vendors doing it already. Host might send an NS to router from global source and trigger neighbor discovery process. However, it would not work for optimistic addresses because it's explicitly prohibited. Host might send an RS from global address, which will trigger, again, packet being sent back to host. However, it would not work for optimistic addresses if routers do multicast, because you cannot send an RS with link layer address in RS. So if router is responding with unicast, then router will trigger address resolution. But if router is doing multicast, it will just respond with multicast and no entries will be created. We can ask routers to buffer more packets. I think security people wouldn't approve. There is also idea to trigger address resolution every time the router routes some packet for which it does not have entry already. I kind of concerned here, as far as I know, yeah, again, some vendors do that, but I think this connection between forwarding and the control plane might be tricky. So, proposed changes. When host gets a new global address configured, it should send an unsolicited NA with override flag set to 0, and I forgot to put it in the draft. About override flag, I will update it in 0.1. So setting override flag to 0 means we would not disrupt any existing cache entries. And routers may or should, and I'm not sure about this, should create a stale entries when they receive unsolicited NAs and there is no entry for that address yet. So actually, because RFC currently say unsolicited NA should be discarded, I think may does not even violate the current statement. Should not means may, but I believe we probably should say should here because it's a good idea. If you have a host on the network, then probably it makes sense to create an entry proactively. Disruption. What bad gonna happen if you do this? If there is an entry already, then nothing would happen because receiving unsolicited NA might, in the worst case scenario, update the entry state to stale, which again would not disrupt any traffic. It might just trigger additional cycle of neighbor solicitations. If there is incomplete entry, well, this is tricky, right? It means that router already started address resolution, so router has sent a multicast NS. Then my new host sends this unsolicited NA. In this case, entry changed from incomplete to stale, and it will sit in the stale until the rightful owner responds. So I'm talking about situation when someone might have that address already. Because we can expect that solicited NA will have override set, then the target and target link layer address included, then stale will become reachable. So the only moment when some traffic might go to the wrong destination will be between receiving NA and unsolicited NA and before solicited comes. But in real life, the traffic would be dropped anyway because before solicited NA came, there is no entry, right? So I did not find a scenario when it might be disruptive, but I might be wrong, right? So I would like people to read this draft and tell me where I'm wrong. Eric, you already found when I'm wrong. Good.
If the neighbor, Eric Klein, if the neighbor is in probe state,
if it's in the probe,
then you receive an unsolicited NA, you haven't verified two-way reachability.
Yeah, okay.
And short-circuiting it by saying...
No, wait. As far as I can remember, if it's in any state except incomplete, it does nothing. It will just move it to stale. So we're not going to update the cache. There is no condition in which any entry except incomplete might be updated. Yeah, expertscape.
So there's one thing that you're not... In general, this makes a lot of sense. The nitty details is about this doesn't specify whether you set the override flag in this or not. And 48, set to 0. Oh,
Yes,
I didn't see that in the draft.
Yes. I just told it. I forgot to put it in the
I
draft.
read all of the purple stuff.
The mistake was to read the draft.
Exactly.
Yes, sorry.
And I was attracted by the purple color and I didn't read that line. Okay.
Yeah,
If you don't
sorry.
set override, yes. then I do.
Sorry, I noticed it yesterday, but I was thinking it doesn't make sense to submit 0-1 like 10 minutes before the session, right? Yeah, I will update it in the draft. Yeah.
Dave Taylor. So on the previous slide, I think, I have no problems with the slide and should. Yeah, sure. I think what I wanted to observe is that for the router behavior, my reading is that on the slide that you had a ways back that you said this is true for hosts but not for routers or whatever, where it was a should. My belief is that any router that does this is still compliant with 4861.
Yeah.
It just doesn't follow that should. So this is just an elaboration on when you might not follow that should. This is not actually any change to the router behavior here.
Yeah.
This is just an informative elaboration on what should means. And for a router, you probably don't want to follow that should. That's what you're saying here.
Yeah. I just didn't want to put too much stuff on the slide.
So that's why the bottom half I can't argue with because I believe that's already 4861 compliant. The top half of this is the only thing that you're actually proposing as a change, and that's the one that I'm saying I don't see a problem with that offhand. Although you might want to say that this whole thing is just a may because the host isn't broken per se if it doesn't send a bunch of back-to-back things or whatever. And so it's really, this is more of a IPv6 node requirements question, right? You want to claim that all the legacy stuff is no longer compliant, or do you say it's compliant, it's just not optimally efficient, okay? And so that's what I mean by, is this just a may? Is this in a separate document that's a may or optional or whatever? That's the only question that I have.
So basically, initially it was v6 ops because I was thinking we actually not even updated anything in 4861, but then it was suggestion made on the list that it's actually a protocol change because now we suggest that host should send some packets.
Right.
Here I am.
So I looked at 4861 and checked my memory, and if I assume I was looking at the right places and then missing other place. It allows sending unsolicited, gratuitous NAs right now, but it does so in the condition that your link layer address changes.
Yeah,
So like
yeah.
you just had a change in your MAC address or something like that, and you want to proactively do it. That's the only case that's called out in there that I've noticed so far. What you're doing is you're adding a second condition
Yes.
that says, I'd like to do it as soon as a new address is configured, and that's the part that's the addition.
Yeah. So basically, proposed change, actually adding a paragraph just after that one. Yeah.
Praveen, Microsoft. Actually, I think like Windows hosts would at least send the gratuitous NA right after duplicate address detection completes. So this is already happening on the network.
Yeah, so what I'm suggesting, you might want, if you're using optimistic DAD, you might even want to do it before, because with override flag set to 0, you're not disturbing anything.
Sure, yeah,
so
makes
because
sense.
again, systems which are using optimistic DAD probably do it for reason because they want to start sending traffic as soon as possible. So theoretically, you might get return traffic before your DAD completed.
Yeah, makes sense. Thank you.
Eric Nordmark again, just you going back and forth with Dave. In the case that the MAC address changes, you want to set override to true, right?
I think it says you may or may
The
not.
spec says in general you set it to either one, but in practice, if you want to get the benefits, in that case you would set it, and here you wouldn't.
Yeah. So like again, I will update the text. Here is a question to the audience: if does it make sense? If does, can we call for adoption? And the side question actually is, currently V6 ops draft enumerates all possible solutions, suggests that we are doing those two things, and brings it here. Shall we keep all possible solutions in this draft or keep it in V6 ops? I don't have opinions, it's just a matter of where we document stuff. So
one question, one other change you're making is that the unsolicited NA will now have all routers destination address as opposed to all host.
I do I did forgot to put on the slide. Yeah, just to minimize the noise, and we might send it to all hosts, but I don't think it's useful because it's actually intended for routers, and I do not think it violates any existing standards, because I think the current standard says usually the destination of unsolicited NA is all hosts. It's not even, I do not even see it as a requirement. So suggestion is to send it to all routers, but probably we can send it to all hosts.
Dave.
Dave Thaler, I came up to, because you asked the question of, does it make sense and what should you do with the all possible solutions and so on. And so my comment on that is, for the parts that you showed in the proposal, yes, that makes sense. And I think it would make sense for 6-man to do that part. As far as what to do with the list of all the other possibilities, I would say leave it in the expired internet draft, which will always be accessible, but don't publish it as an RFC. And the reason for that is if you publish all possible ways to do something, people will start writing internet drafts for every single one of those over the next 20 years.
My understanding is currently all possible solutions belong to V6 ops draft in the format. Here is the problem. We had all those ideas what to do with them, starting from doing nothing. And we decided there are two good things we can do and what we did in 6-man. However, as far as I know, some vendors already doing some of those additional things as well. And I don't think they have pros and cons. So at least, we can probably keep in V6.
If there are things that operators can already do by tweaking things, meaning things that are already compliant and you're changing which things are configured, which RFCs are turned on and off, and whether shoulds or mays are on and off, that part is fine. If you're saying, here's a bunch of ways you can invent new technologies for, new mechanisms for that involve changes to RFCs, I'd say don't put that in an RFC. Just leave it in your in a document right now that gets not published.
Yeah, so he's clearly answering your question that don't leave those other solutions in the other draft. Take them out, and they will still exist forever in an expired draft.
Suresh Krishnan. So it kind of makes sense to me. There's like some work I think you need to do, specifically the gratuitous NAs going to the all hosts as well as all routers, because it's not clear with the new text in the draft whether you're still sending the all host one as well or just sending the all routers one. So I think you need to clarify that.
Okay, point taken.
Does it make sense?
Okay, so the chairs have now been on training for how to get consensus in a working group. So this is not going to be a hum for adoption. It's going to be a hum against adoption. So, but any objectors here who think that doing this solution that is proposed here would be a bad idea or break something? Can you please get up now? Or if you don't dare to get up now, you can hum quietly, and we'll count that as an objection.
Eric?
Eric Vink, again, individual contributor. I like this, don't take me wrong, right? So I did not hum. My only concern is that at V6 op, you come up with 5 solutions, then we end up with 5 solutions here. The router vendors implement 1, 2, 3, and the host vendor implement 2, 4, and 5. We end up nowhere.
So I think, again, V6 ops drafts, enumerating them and saying pros and cons, and for some of them saying it's not going to work at all. For example, as I put here, neither sending NS or RS would work for optimistic addresses, right? So I can put them in the section considered by discarded, right? I can, rephrase V6 ops drafts, obviously, because initially, until now, I don't even know if it's all makes sense. I would expect some people to come and tell me that I'm going to break stuff, right? So it's obviously we can rephrase the draft.
So from a 6-man perspective, I think V6 ops have presented us with a problem, and we're picking a solution. And I think, as Dave and Bob said, we can leave those alternatives in a expired internet draft. We certainly don't want to include them or talk about them here. I think we're going to pick one solution and standardize
As long
that.
as we pick one solution and not a solution.
Yeah. So I see Fred coming up representing V6 Ops, and we'll hear his side of the story.
Fred Baker, who knows nothing about V6 Ops. I guess my question is, what expired draft are we talking about? Are you saying that you want V6 Ops to take Jen's draft that we have and just let it expire?
She will do an update to that draft, so they all won't be in the plus whatever, I don't know what version it is now. They'll go away in the next version, but the current version will,
So she will have two drafts in V6 Ops, one of which we will allow to expire.
No, she will do a replacement draft, which will only have one solution in it.
I agree with Bob's articulation. So,
But that
what's
old
the draft
draft
number
is
you have
still
right now?
in the repository somewhere.
Jen, what's your draft in V6 Ops? Is a draft -0 what?
It's currently 00 in
-0
V6.
0. Okay.
So I'll do
So
01
we're
with
saying
removing all
01
the stuff.
would remove the complete list and then could still go to RFC. And so the thing that is expired is probably the wrong term. The draft 00 version will always be available with the full stuff, but the one that draft 01 and later to RFC will not.
That I understand.
Good.
Okay.
That's what Bob was trying to say.
Okay, cool.
Yeah, thanks a lot, Dave, for that clarification. Yes, I mean, our reading both of the V6 Ops list, 6-man, and this room is that there is consensus to adopt this document. I don't think it is necessary to do a hum for any objectors.
Well, you did.
Did I? Yeah, I didn't hear anything. I didn't mean to do one. I guess I did that.
Well, you did.
Good.
Okay.
Super. We'll
Thank
confirm that on the list. Thank you, Jen. Okay, Giuseppe, are you here?
Hello, this is Giuseppe, and we are going to present the IPv6 application for the alternate marking method. So just a quick recap for this methodology. So this is basically an OIM performance measurement technique that allow to measure the packet loss, delay, and delay variation. And you see the reference. So we have an RFC 8321 basically for point-to-point measurement, and also the extension that we consider as this evolution that is multi-point alternate marking draft that allows flexible application of this methodology. But basically it is, as also the name suggests, is the alternation of two bits value, for example, between red and blue. When the red counters are running, the blue counters are still, so we can get the counters during the still period, and by comparison, we can calculate the packet loss. So basically, it's very simple. And same methodology apply also to delay and delay variation. What are the main strengths? It works without OM packets that divide precisely the traffic. So we don't need to inject nothing in our flow. It works on real production traffic. It works also if you have out of sequence. So this make this methodology very flexible, and it works on not synchronized network. So you don't need a strict synchronization because the change of marking is a sort of auto synchronization signal over the network. Regarding the delay, just we have two alternatives. One is single mark. The second is double mark. The single mark, we use 1 bit, L bit, so you see the alternation bit 1, 1, and 0. You can do the alternation for fixed period also, or based on fixed numbers. So it is the same, and change also only the implementation. And so the L bit it's used for the delay, and for the packet loss, while for the delay, you can take the reference just for the first and last packet of each marking period. But this doesn't work so well in case of reordering. So in this case, you can also calculate the average packet delay and delay variation. If we have the ability to have a second bits, in this way, we can use the first bit for the packet loss and second bit for the delay. In this case, you can select some packets within each period to follow this packet along the path and to calculate the delay for these packets. In this case, you can have a more informative information because you can calculate the minimum, the maximum, and all the statistics for the delay. So you can have more informative metrics. Okay, that is basically the methodology. If you want more detail, come to me or read draft in IPPM. What about IPv6? We already have presented a draft, I think in London, that reported a summary about some alternatives on how to apply these methodologies. And for example, we reported some alternatives that we already investigated about the use of IPv6 addresses, the IPv6 flow label that we cannot use, of course, because IPv6 addresses is too expensive. The use of flow labels is against the RFC 6438 because it is based on the ECMP. So in this case, if we use flow label to mark, we can change the path. So in this case, it's not good to make performance and to change the path at the same time. So the only way, in summary, we can say that the only way is to use an option header if we consider the IPv6 or the TLV if we consider the SRH. Our idea is to define and generalize alternate marking data fields. We have made, considering all the deployment use cases that we have, we think that we can generalize this data field. So as I said, we need two marking for bits, two marking bits, so L bit and D bit, one for loss and the other for delay. We consider also a flow monitoring identifier, so a 20 bits that is not like the flow label, but allow us to make a flow identification. This is not crucial for the methodology, but can be very useful for the deployment reason. And then we put some reserved bit for future use. And these data fields we want to encode in an option header or in an SRH TLV. So we investigated some alternatives. Also, there was some discussion on the mailing list, and you can use this option as hop by hop, as destination option header, depending on which measure you want to activate, or in an SRH TLV. For example, we have made a summary of the alternative options that you may have. You can have a destination option. In this case, you can measure the end-to-end with the destination address. The hop by hop option, if you want to measure on every router on the path. An SRH TLV, in this case, you can allow the metrics on every node along the SRH path, and also a combination of destination option and SRH, but this is basically the same of SRH TLV. So we can mention only for cosmetic reason. And as I say, this is not 0.0 version because we didn't present last time. This is the 0.1, and we got several comments on the mailing list. In particular, I want to thank Bob, Paul, Tom, and Stefano that give us some feedback and improvements to the document, in particular to investigate the alternatives and to adjust sometimes the wording of the draft. As next step, so I think we have found an agreed way to apply the RFC 8321 and its evolution in particular, because we look also to the multi-point alt mark methodology for IPv6, and we ask for comments, feedback, and of course we would like to go for the adoption, but it's up to you.
So what is the relationship between the work going on in IPPM and this document?
Do you mean the alternate marking or in Band-OM? Which?
So alternative marking. I mean,
Okay,
there's
okay.
work on this
In IPPM, the draft are only experimental because we cannot make standard with this kind of methodology. So in IPPM, we are basically we are described the general methodology. So now we want to apply in a real protocol.
So what I'm trying to ask, I think, is the distribution of work between IPPM and 6-man. If 6-man is left, defining the TLV format and perhaps rules of which extension headers they go in, and the marking logic, if you like, if that's going to stay in IPPM, for example. And I guess
Usually, if I also look at the experience of other methodology, the protocol specific application are made in the working group, for example, here in 6-man. But the methodology, the general methodology, we are working, of course, in IPPM because it is protocol agnostic, we can say. So you can apply to other kind of protocols. And
How many people have read this draft? Okay. Hands down. I counted you.
We'd probably like to see more discussion, or well.
Yeah, I think let us have a chat with the IPPM AD chairs as well, and then certainly want to see continued discussion on the mailing list as well, and figure out on the mailing list, and then we'll see the next step as adoption. Yeah.
Okay.
Super.
Thank you.
Thank you. Okay, Mark, you're up.
Hello, Mark Smith. First IETF I've been to sort of in a long time. I've been on the mailing list for a very long time. This is a bit blue sky, and I've fallen out of the habit of using bullet points, so you might only find 2 or 3. Okay, whoops. IPv6 formal anycast and functional anycast addresses. Current IPv6 anycast addresses are from within the unicast address space, and as RFC 4291 says, they're indistinguishable. To configure anycast, it's usually a flag on an interface when you configure an address. What that does is it disables duplicate address detection, and to get them available in the routing domain, you have to inject it somehow. It's treated as unicast by routing domain protocols and other hosts. I think that's a negative sometimes. If you happen to have duplicate route table entries, that's a fault if it's unintentional. But if it's intentional, then it's probably anycast. The forwarding scopes or domains for these types of anycast addresses is fairly coarse. We have global, local network, and link. What about something a bit more discrete, such as realm, administrative, or organizational? Another thought or example is that applications or protocols can't distinguish unicast or anycast addresses without manual configuration. An idea is to have multipath TCP or UDP established using anycast and then switch to using a unicast, and it would be useful to be able to distinguish the address types. So the thought I've had is to have a formal IPv6 anycast address space. My thought is AA, so SHATE, or possibly FA for formal anycast. they're both available. This is actually not my idea. The earliest RFC, one of the earliest, if not earliest RFCs on Anycast 1546 suggested two ways of supporting Anycast, and one of them was to have a well-known class of addresses, with the advantages being it's easy to determine an address as an Anycast address, and well-known Anycast addresses are easy to support. If we have a look at some of the existing Anycast addresses that are already defined, within a subnet, we have the top 127 addresses. They're reserved for this purpose. And there's a couple of specific reservations, the reserved subnet Anycast range. There's also the mobile IPv6 home agents. The other one that's within a subnet is all zeros for the subnet router Anycast address. These have different scopes, and the scopes depend on the type of unicast prefix in use, such as global or link local, etc. There are some others that are globally assigned by IANA. The discard only address block, 100/64. That's a network local, even though it's a globally unique address. The port control protocol Anycast, global. In theory, that's supposed to be globally reachable, but if you look at what PCP is about, it's unlikely you'd have a random PCP server somewhere out on the internet that you want to send to. There's the turn one, and then there's the AS112 service one. Looking at these reserved well-known addresses, I think there are three common properties. They're encoding services and functions. They're not actually host or interface identifiers in a unicast sense. They have different number spaces. So we have the GUA global for some of those, non-GUA global and the subnet ID, and they also have different forwarding domains or scopes. I realize that these properties are actually similar to what multicast has. And so if the idea of having a formal Anycast address prefix is good, then I think Anycast is both similar to unicast, and it's also similar to multicast in the sense that it's being used for services and functions. Sort of thinking about where that puts Anycast, it's perhaps can be imagined to be halfway between unicast and multicast, one-to-one, one-to-any, and one-to-many. So if we were to have a formal Anycast address space, then we could seek some inspiration from multicast. We have scopes, we can have an embedded unicast prefix, we can have some IANA well-known function or service IDs, and also local network service or function IDs. The proposal for an Anycast, formal Anycast prefix, AA as I suggested, then have a visible scope, which I say the same values as the multicast scopes. Then 4 bits for an Anycast identifier format. This is to allow flexibility in the lower 112 bits. And this is also because I realize a /8 is a bold ask, so I should future-proof it a bit. Possibly a new destination unreachable code for edge of visible scope reached. An interim alternative would be communication with destination administratively prohibited. In terms of destination address selection, the formal Anycast would be preferred over unicast by default, but there are some applications such as that multipath protocol example where you might want to prefer unicast. Well, that can be easily, they can easily be selected because of the well-known Anycast prefix. I had this idea of the thought of hosts being able to register their Anycast addresses, and then when I was preparing this presentation, I found a internet draft from 2001. I've been on the mailing list since 2002, so I missed this, but the idea is sort of already there. Another thought that occurred to me was using Anycast addresses for hop-by-hop processing of packets through a network. After the local hop processing, which obviously starts to relate to what's happening in Spring and so on, after the local hop processing, there's an RPF check on the source address, same as multicast. However, we need to exclude the local node Anycast destination address instance to prevent a packet looping around within the node. And then finally, the forwarding is based on the remaining Anycast routes. This is neither unicast or multicast forwarding. It's got bits of both. And it's actually a series of host hops. If we look at RFC 8200 on what a router is versus what a host is, the thing to remember about these definitions is they're really functional definitions, not device definitions. So A router is a node that forwards IPv6 packets not explicitly addressed to itself. Well, this is a destination address on a device inside the network that is that the address is assigned to. So that would actually make it a host, and therefore this processing would be a path of host hops through the network. Regarding the first format, I think I've mentioned it, the functional anycast. This is the breakdown of the lower 112 bits. There's an anycast domain prefix, which would be a unicast prefix. This is inspired by multicast RFC 3306. All zeros identifies an unspecified or this domain. And this also provides an opportunity to do anycast more specific route aggregation at this point. There's some reserve bits and then a prefix length of 64 bits, sorry, 6 bits of prefix length, 0 means 64. There's flags, again, inspired by multicast. However, in this case, there's only 2, t equals 0, t equals 1. T equals 0 means that the anycast function ID on the far right is a well-known IANA assigned one, similar to multicast. T equals 1, a transient local anycast domain assigned, similar to multicast again. This is sort of new. This is to introduce a local instance of the anycast address. An example could be that you are developing an anycast service and you also have a production version. This is a local instance, configuration, revision, etc. number embedded in the address. This is a bit of a soft field. It could also be used to extend the anycast function ID to 32 bits if that would be useful. And finally, the lower 24 bits, the anycast function ID with the t equals 0 or 1 flags determining whether it's IANA assigned or not. It could be a bit simpler. I'm not sure about the prefix length field. It's an informational field, and possibly with 1 flag value could be encoded somewhere else. Some example uses. I've tried to set this up quite a while ago to have an internet DDoS impervious ISP anycast DNS resolvers. The requirements would be reachable to all of an ISP's customers, but not reachable from the internet. And then it's attributable to the ISP. Sure, your customers could DDoS the DNS, but they have a good interest in not doing that because they break their own internet. So we would form that using a formal anycast prefix of AA, as mentioned. This would be a new scope, a visible scope of a network service provider, which would be greater than organizational, but smaller than global. And then the anycast identifier format of functional anycast. The anycast domain prefix would be one of the ISP's globally unique GUIs, 2001 DB8. Prefix length of value of 0, meaning /64. Flags of 0 because it's a IANA assigned anycast functional identifier. Local instance, since it's in production, 0, or whatever the ISP decides, but 0 seems logical for functional. And then these would be some example IANA assigned well-known function IDs of 53, 54, and 55. So these would be the anycast addresses for DNS that we would distribute to our ISP customers. AAB0, 2-1, DB8, 53, 54, 55. Another example to fill it out, this is an organizational Thingo service in development. I don't know what a Thingo does, but it's locally defined. Again, AA/8. This scope would be organization, and again, the functional anycast identifier format. Anycast domain prefix, the organization could put any of theirs there, but to reduce visibility, they might use ULAs, so FD, XX, YYZ, etc. Again, prefix length value of 0 indicating /64. This time the T flag is 1 because it's a local organization assigned. The local instance will be 6A because this is the IETF106 revision. And finally, there's an anycast function identifier of 54 4E47, which is an arbitrary number and is TNG in ASCII. So that one's a bit longer, but it could be encoded in DNS. But there's AA80, FD, and the ULA prefix, the 80 for the T flag, and then 6A, 54 4E47. The status, I sort of have worked on this for quite a while. The idea is sort of mostly baked, I think. I've been working and thinking on this for about 3 years. I had no idea that whether it would pan out or not, and asking for a /8 is pretty bold, so I think you've got to justify that a lot. As I mentioned, I discovered the host-based anycasting using MLD was seems to suggest there's been some thoughts of doing this sort of thing before, as much as it was 20 years ago nearly. And I'm at IETF106 to present, so I thought I'd see if I could. And I'm grateful to the Internet Society for sending me here. Any thoughts or suggestions or questions?
Yeah, we would really like to hear comments at the mic line, please.
Rajiv, sorry, Cisco. So clearly there's a value in identifying that this is any cost or not address. And some of the large scale V6 deployments I've been part of, few of them require such an identification. And the way we address them by just using bit, which was part of the GUA, and using that within that domain. And that worked out reasonably well. And it reasonably well to the point that we could filter it if we needed to. The best part, which was an advantage, was that we could still keep our summarization boundaries within the GUA as we would need. And that was the best part, in my opinion. With this, I think that becomes a downside. Because now this is independent of my GUA. That means I got to create additional routing entries, even if it's within that AA or FA, whatever that might be.
Yep.
So I'm sort of 50-50 on that.
Yep.
Thank you.
Eric Klein, yeah, sort of similar to that point. I was sort of wondering, operationally for your network, for a network service provider, what's the difference in work required for using one of these and routing /128s as anycasts throughout your network for various services versus just using a GUA that you might have, or 3FFE for that matter? Sorry.
Look, the way I look at, I like to try and make things easier. Having identification, I look at the troubleshooting example and think it would be useful to immediately know it was an anycast address rather than potentially having to investigate configuration and so on. It seems useful to me. Certainly when I looked at trying to implement DDoS impervious ISP resolvers, not having it globally reachable would be quite an advantage.
Isn't that a matter of the service provider's filtering policy?
Yeah, except you get the 100 gigabits of traffic before you throw it away. Whereas if it's completely unreachable off the internet, no one can send it to you.
But they can send that to you anyway on another address, on another service, no matter
That's
what.
true.
If they know that you have any address prefixes allocated to you at all, then they can still attack you.
Michael Richardson, I liked it on the list. I still like it. I think that one of your use cases was the quick case of negotiate on anycast and then move elsewhere. And I would like that use case I believe that's the killer use case. Unfortunately, it doesn't work if the address is not visible announceable to the rest of the world, right? So
that's true. The draft's 30 pages, so there's bits and pieces I've left out of here to try and just get the idea out there.
So that's my thought. So maybe there's actually two spaces of what we need. There was a recent thread on the ECN sanity list about equal cost multipath. You may have seen this thing. Apparently they were switching on the ECN bits. And so if you turned them off in the middle of your TCP connection, you then went to the other anycasted DNS server over TCP, which didn't work, right? So making that work would be good somehow to identify it or to make it clear to the ECMP that this was an anycast address and it shouldn't do quite the same thing. That would also be great. But I don't see how to make that work and also make your bulletproof DNS server work. We had a need for some kind of an anycast address in the HomeNet space, where we want to reach whichever thing has stuff, and it wasn't at all clear to us how to do that, except that we would wind up saying, okay, well, because the HomeNet was going to be would be all ULAs, and we might not even have address resolution. We want a special magic address that we can essentially hard code.
Yep.
So the AA thing would be useful for that, even if it doesn't solve the quick problem. So I think you have multiple use cases, and I'd like to proceed forward
Yeah.
with investigating this.
I started the gap in the draft is more or less use cases, but I sort of came up with about 6 different ones, perhaps internal, multipath, TCP, and so on.
Jen Linkova, I'm kind of sitting on the fence here, right? So I would not use it because I do not see use case really, but I guess if someone else believes it's useful, yeah, why not? I'm a bit concerned about, again, we're going to live in the world when you have any cast in your prefix and any cast which belongs to unicast address space, right? Because not everyone going to renumber, right? But however, there is one good thing about this, and I don't see it mentioned in your draft. From my perspective, the biggest problem with any cast is load balancing. If you can say router must not ever use L4 information for load balancing for any cast addresses, and only use L3/flow label or whatever, that would be beneficial, right? So I don't need to explicitly configure that, and it would be done automatically. That might be worth mentioning in the draft.
Yeah, and that's, I think, to some extent, the idea of using multipath protocols that just establish with any cast, which is, say, half a dozen packets, and then switch to unicast, potentially can address that with intelligent unicast.
The problem which exists in real life, you send one big packet, you fragment it, and the second part never reaches the same anycast server as the first part, and then and tell me about interesting protocols working over this.
Jordi Palet. I am wondering, one of the advantages that I see with the actual Anycast is that the host don't differentiate it. And I think that's very useful. So I see just the other way that you are looking at.
Well, a host isn't forced to, I mean, hosts don't have to do anything to implement this. This is really, it's a remote, what a remote address appears like. So hosts could treat this as a unicast address the way they do today.
I don't know.
It's not forcing
I am feeling I'm missing something, but I think that's the best property that we have from the actual Anycast. I don't know. I need to read again the document maybe, but I think that's the best that we have with Anycast actually.
All right. Thank you very much. Appreciate the time.
Thank you. And I think we'll continue the discussion on the mailing list.
Thank you. Sorry the draft's so long, but thank you.
Thank you. Okay, so then we have 2 sort of semi-lightning draft that we're given a little bit more time today. The first one is asymmetric IPv6.
Hello everyone, Guangpeng Li from Huawei. Today I'll introduce asymmetric IPv6, a flexible usage of IPv6 in edge IoT scenarios. Asymmetric IPv6 will use the shortened addresses because of the restriction of the MTU and the bit rate and bit rate regions, and the compression approaches like 6LoWPAN may not work here because of the edge routers may be constrained. So asymmetric IPv6 will route directly on shortened addresses to avoid compression and decompression hop by hop. So the method includes define a short address length n and see the rest of bits as the prefix length. And the RibFib can use the short addresses for intra-domain forwarding, but full addresses outside. So more unnecessary headers can be elided through using a flexible header encoding. So the short address length, is decided domain by domain when the networks start up, and it will be configured into or learned by local devices. So asymmetric IPv6 reuses RA message, but need to define new flag bit for short address mode. So for short address configuration, a new joined device gets SRA. Here means short root address or for from RA message, and then generate a short address accordingly. This address can be used for the interface address only if passing validation of DAD, or revise the DAD. If not, then regenerate another one. So for the encapsulation, it's very simple. We use the adoption layer like 6LoWPAN, but the new dispatch should be assigned for asymmetric IPv6. And the following, we use encoding bits. For outward communication traffic, the gateway must add prefix to form standard IPv6 addresses, and the corresponding operation is for the inward traffic. Prefix bits will not attend to the intra-domain communications. At last, considering there normally be a few outside IPv6 addresses involved, so the asymmetric IPv6 can allocate a short delegation for the outside IPv6 addresses here, but new options of RS and RA message should be defined for that. Okay, any comments and questions? Thank you.
So I think I have one question. What is the packet format that the application on the inner side looks like? Is that an IPv6 header, or is it a shortened, compressed header?
You mean the format?
So on device A, the IP stack on device A, what does it see? Does it see a compressed header, or does it uncompress it and see a full IPv6?
Ryan Carpenter here. Do you mean above the socket API or below the socket API?
Well, I write code on devices that don't have socket API, so I just look at the packet. So what does the packet buffer that I pass up to my application of some sort look like?
That's a good question. I'll tell you my preference. It depends, but I would suggest that it should see the expanded packets, but just because that's probably how the code is written. But actually that isn't necessary, is it?
Right. But at least it has the information, or it's intended that it has the information that it can actually uncompress the header.
Yeah, well, I mean, we can recreate a complete IPv6 packet. So if that's what you want in the API, that's what we can do.
Yeah, this takes us back, Fred Baker here. This takes us back to a discussion that happened before IPv6 was standardized in RFC 1883. Should we have a variable length address or a fixed length address? And there were proponents of each side. So this is a new protocol or a change to the IPv6 header, which would insert a length field and a pointer to where in the address are we starting. And I guess my first question is, how does a host know where the edge of the network is? How much is enough of the address? You know, I'm not sure a host has that visibility into the network.
This is Brian. I think, yeah, it knows, this went past a bit quickly in the presentation, but it knows the address length in use within the domain, and therefore it knows that some addresses are short and some addresses are long, and which is signaled in the packet by magic bits.
How does a host know what to signal? You haven't answered the question.
It doesn't need to. I mean, it's in the domain where this is being used. It either uses a short address or a long address according to what the destination is. I suggest read the draft and then ask the question again.
Let me, so I'm just asking a question, not the chair question. So I looked at the draft, and in the beginning, it talks about the motivation, if I understood this, the motivation was for 5G networks that are very restricted in bandwidth and packet size limits. And then it had a reference to some sort of document that was sort of talking about the characteristics of 5G networks. But I looked at that document and I didn't see anything that justified the assumptions, or the problem that this was attempting to solve. So I don't understand what the use case for this is.
Okay, this is mainly for the constrained network domain in the edge networks. So maybe 5G, maybe not 5G.
Okay, well, I think there would have to be a lot. I think you have, at least to convince me, you have to convince me that this is a problem that needs to be solved. And then, there's we have a zillion different ways of doing compression already, and why we need a different one. So,
Brian again. I mean, in a sense, that's why we took this draft to 6LO as well, because that's their business. And we didn't get asked that question there because they understand the answer, if you like. So it probably needs more context for people who are not in the 6LO world. But we thought we'd better mention it here anyway, since we're mucking about with the IPv6 packet format since 1883.
Suresh Krishnan talking as the responsible lady for both 6MAN and 6LO. I personally also think the justification is not clear, because one of the things it says in the draft is I don't want to talk about SHIC, for example, right? Because there's compression overhead. That's not obvious to me at all, because SHIC can compress even higher than this and get a better, smaller packet format while keeping the IP header pretty much intact, like before compression. So and specifically what Bob was saying, the 5G document pointed to in this draft is a user plane analysis draft, which talks nothing about constrained networks. It's more about, okay, do we use GTP or SRv6 and all the other mechanisms? So I think it's a wrong reference, personally. So you might find a better reference for it. Probably if you look at NB-IoT or something in 5G, maybe you'll get a better reference. I think that was Bob's point, because I know about this, I'm giving you a better option for a reference. But I think it's good that 6MAN is aware of it, but it probably needs to happen somewhere else. Maybe 6LO or LPWAN or somewhere would be a better place for this to be discussed. I know you presented this in 6LO, and but the point is I don't know if there's room for yet another compression format that's different, unless you justify that by saying, hey, this is the reason the current things don't work for me, rather than saying, hey, there's a decompression overhead, because it's not clear the overhead is very big.
Okay, I come here mainly because we reused the RA and NADAD mechanisms.
No, I understand the solution. I'm just saying, is the problem big enough for us to come up with a completely new solution? That is the part I'm not clear. Maybe Brian wants to take a shot at it, but that's the part that's not clear to me.
Eric Vink, an NVIDIA contributor. I must admit I didn't read the draft, but may we assume that the node using the short address has the knowledge of its full 128-bit address, so that AH and ICMP generation will work?
Sorry, one.
That's a good question. I think we have to make sure that the same time we tell the domain that its address length is 32 or whatever, we also tell it what the prefix to that 32 is for that exact reason. Thank you.
Rajiv, sorry, Cisco. So I've got two-part question. One, in the slide, you mentioned that the compression decompression algorithm takes resources and the MTU may be low on the physical MTU. If you could clarify how low are we talking about, the MTU, and how much resources consumption for compression decompression is really a problem. So any numbers you could share, that would be really useful. And the second part was more on the solutions. If two hops are exchanging or negotiating the value for that n, because you're calculating 128 minus n, how high the n could go? There's no binding, there's no constraint that I've noticed in the draft. So could I go as low as 2 bytes? Could I go as high as back to 128 bytes? So the negotiation, even if it's between two hops and then it goes in a cascading manner, how does it really work out? That I couldn't really follow that.
Yes, for the first question, very good. We will find the detailed information, and later maybe we explore it in the drafts. And for the second one, the initial negotiation will induce the local length increase and not decrease. So, but if originally the domain gateway decides to use 2 bits length is okay, but the scale of this domain network will be small.
Okay. So I think we're sort of out of time for this. So let's continue this on the mailing list. Thank you very much for speaking. Okay, our last speaker for the session.
Hello, everyone. This is Hao Song from FutureWay. Today, I'm going to introduce the idea of supporting postcard-based telemetry for SRv6 OEM. We all know there's a new class of data plane telemetry techniques. We call that on-pass data telemetry, which can directly collect the data about the user traffic by embedding some actual instruction header into the packet. It's very important for SRv6 to support OEM and application-aware services. However, we all know that due to the SRH, the header overhead of SRv6 is already pretty high. And then it's problematic to add even more header into the SRv6 header. And also, by introduce another new header may introduce some actual ambiguity to the encapsulation because it's not clear where you will apply this function. It's under each underlying hop or it's on a per section basis. So it's not clear. So a better solution is use what we call the PBTM. It's documented in another draft we submitted to IPPM. So the basic idea is that we, instead of insert a new header into the packet, we just use a single bit to mark the packet if we want to collect any data about it. So once a segment router receives this packet and detect this bit, it will just based on some pre-configurations and collect some data about this packet and send it directly to a collector using a postcard packet. So it solves the performance issue because it doesn't process the user packet directly, just detecting a mark from it. And it avoids any packet size inflation, and it avoids the trouble of encapsulation. And it guarantees better security for the data exported. And also it has actual benefit to be able to detect the location of the drop once the user traffic is dropped. But it also introduced some new issues, like since we have a bunch of postcards sending from many segments routers for each single packet, then we need to have a mechanisms to correlate these postcards. And also it introduced a little bit higher export data overhead, because each piece of data from each router, you will need an independent packet. And also you do need to configuration, because there's no more instruction carried by the packet itself. However, all this issue can be correctly solved. And therefore the proposal is actually quite simple. Since we already have a flag field in the SRH header, then we can just borrow one bit from that part. It's not necessary to be the first bit. Any bit will do. But use this single bit as the indicator. If you ever want to collect the unpassed data about this packet, you just enable that bit. And how to solve the packet correlation problem? There's some common methods already be documented in our postcard-based telemetry draft. And here for SRH, we have actual advantage, because we already have the segment list, and which can help to us to order the postcards correctly. And if we need some extra information, such as a flow ID for the flow correlation, or sequence number for the packet correlation, then we can include them as simply as a TLVs in SRH. So I think that's a pretty simple and elegant solution. Therefore, I think it might be considered as a formal document in the working group.
Yeah, Suresh Krishnan. So not speaking as AD, but as somebody who has an in-band telemetry implementation,
yep.
I think the idea of having something in the payload protocol to mark in-band telemetry collection doesn't scale. Okay, so if you want to do this for every protocol for which you want to do in-band telemetry, it's not going to work. Okay, so you need to do something outside the payload for which you need to collect. So I think it's not the right approach.
Why?
What about for encrypted HTTP packets? How do you signal you want to have telemetry for that?
I just at the head of the SRH parts.
No, let's say there's no SRH. Let's say there's no SRH, right?
Yeah.
You have a HTTP packet that's flowing through your system, right? And you want to collect telemetry for that, right? Where do you signal it?
So this is about segment routing. So
I understand. But you said this is required for in-band telemetry to signal collection of postcards, right? So if you want to do that for every protocol that you carry, including SRH, which is the protocol.
No, this is a specific implementation for SRv6. So the PBT is a general approach, general method. It can be applied to any transport protocols, but this is just a specific proposal how you will apply it to SRv6.
No, but I don't think this bit is required. That's the point I was trying to make, because for every protocol you're going to collect for.
I don't understand why you think it's not required, because sometimes I just want to follow the path of this packet, and I also want to monitor the per segment latency, or any other application use cases for this. If I want to collect this data, I have no other ways to do that. So you have active and passive OEM method, but they don't directly give you the user packets behavior.
No, but if you don't have an SRH, how do you do this?
What?
If you don't have SRH, how do you do it?
Then this depends on different protocol. We might find different ways to do that.
Each protocol does not make sense. That is my point.
Yeah, I'm just saying for SRH, we do have the way, because there are flags, we can just use single bit.
Darren from Cisco Systems. I'm not sure about the IPPM part of this or anything, but it seems like you've got a bit that says copy this packet and do something with it. Isn't that exactly
I don't copy the packet, sorry. I just set this bit in the SRH, and then it's just basically notify the router to send the postcard
I understand.
packet.
So at that router that processes this header, it sees that a bit is set.
Yeah.
And then it does some special something or other.
Yeah.
Okay. And I don't know what that special something or other is.
Right.
But there's a bit that we just talked about earlier that was in the working group document that does that.
Yeah.
So you might want to consider whether you need this bit or if there's something else that already exists. And that's without understanding how you're going to use this. Just it looks like the same thing.
Yep.
Okay, Robin. So Huawei, I added some clarification regarding the storage issue. I think this is we always talk about the SRv6 because in fact, we have some the boundary of the network. Sometimes we think SRv6 may use for the limited domain, not for all the internet. So I think this is some of the difference. Yeah. So and also this one because you mentioned the HTTP packet. So this we may use some of the HTTP is bared by the SRv6 tunnel in some limited domain for the mobile transport like this one. So only this information is export in the mobile transport domain like this. I think this is the scenario, but I think if you think maybe more general for the HTTP or something in application layer, if you need some this direct this information, I think that's maybe other solution.
Okay, thanks, Robin. I'll go after Tal. Tal, go.
Tal Mizrahi. So first of all, I agree with this use case. I agree with what has been said here. That basically this is a different application than alternate marking, but they can both use the same kind of trigger. At the end of the day, it's a trigger for doing something, and I believe it's the same requirement from the data plane. Exactly. So a common solution can be found for both.
Yeah, I agree.
Okay. Wim, do you want to go ahead of me? Or I'll close off.
Wim Hendricks, Nokia. I have a question. Is this in the context of APN6, which was discussed yesterday in the routing working group?
No, sorry. This is the first time I present
No, but from a solution perspective on how you're going to use it, is this related to the, what is it, APN6, which was yesterday discussed in routing working group?
I see. Okay. I think now this is not directly related to APN6. Even the SRv6, because you maybe the is bared, the packet bared by the SRv6 tunnel.
But I mean, you probably have a use case on how you're going to use this, right? For me, this looks very similar what
the use case
to achieve with APN6. And if that's true, I think we first need to flush out whether APN6 as a use case is actually something IETF will adopt and how and so on and so forth. So for me, I think we shouldn't rush into the solution space here. We should first discuss the use case and how it's applicable and how it will, whether it will ever use. Because if APN6, you have lots of, let's say, privacy issues and stuff like that, which were discussed yesterday in routing working group. So my suggestion would be, if it's related to that, let's first flush this out before we rush into solution space here.
I think starting point is about yeah.
Wim, I think now this is now that's the two things. Until now is decoupled. Since this is the telemetry, the in-band telemetry. So this is the SR pass level. SR pass level. Yeah. But the APN that maybe later can combine with together. That is the application level. I think that's even until now, I don't think they coupled together.
Right. This is intent to monitor the segment forwarding behavior and performance. Yeah.
So, Suresh Krishnan, so just answering Robin's point, right? So I do understand why you're doing the postcard-based telemetry. I just don't see why you want to do it for every protocol. Because if you're doing this for SRv6, you probably had to do it for NSH, for some other protocol that's going to go through, right? But if you have it outside the protocol, it's similar to saying like, oh, I want to collect like some net flow information, right? From some kind of packet, and the packet itself has a bit in there which says like, hey, now send statistics. So I think that's not a scalable approach. You may or may not want to do it, but I'm just telling you, doing this per protocol for which you want to get postcard-based telemetry is not going to work.
I'm not talking about applies to every protocol, but here I just talking about how to apply it in SRv6.
Yeah, Rajiv Asari, I think so. I see that it's interesting to be having a packet convey that, hey, do something with me.
Yeah.
And related to what Suresh was saying, this is very specific for SRv6 when there's an SRH in place.
Right.
So I'm just curious to hear your point of view. Why restrict this to that specific use case? Why not just do it on IPv6? There are tons of deployments out there, just the native IPv6. Why not do it somewhere in the IPv6 main header? Just curious, ignoring that whether or not we could do it or not.
Yeah, so if you look at our original draft on the PPT, when we talk about this, we actually give several possibilities to apply this in several different other protocols. But here, because those are high-level method, and it has some merit compared with IOAM. And here, we just give if you want to apply this to support the OEM for SRv6, how you can do that. So then we need to find a place to hold this mark. So that's a proposal here.
Yeah,
If
sorry,
you
my
talking about if you want to apply this to different networks, to different scenarios, you do need to find a place to host this mark. So that's a different issue, not for this working group.
Yeah, why not do it in the IPv6 header? Was my question.
Yeah, so far I don't have a very solid idea how we can do that in our IPv6, because I cannot find a bit to hold the mark. Yeah, so that's the issue.
Thanks.
Brian Carpenter again. I don't quite understand that statement, because we have draft IOAM metal IPPM 6-man IOAM IPv6 deployment from March, which is talking about doing this in IPv6, not in SRv6.
Because that's the user actual extension header.
Yes, you use an
hold it.
extension header. You're stealing a bit in someone else's extension header, but it's still an extension.
But that's the existing header. I don't introduce a new header to the system, because that exactly as I said, the problem here is the overhead issue. I don't want to introduce a new header to expand the packet size further. Yeah.
The point that Suresh is making is that your solution is only universal within a domain where everything is encapsulated and has a SRH. Right. The other draft, which is an IPPM draft, I guess, would work for every IPv6 packet in the world if we decided to support such an extension. So that's the decision that somebody needs to take.
Yeah, thank you. So I mean, this is a lightning draft. I think there's clearly more work needed here, and certainly coordination between IPPM. Spring for this case. You should probably sit down with the alt-mark authors and look at that as well. I mean, there has to be some coordination of this set of markers in packets, for sure. But yes, so let's continue that on the list. So we are actually 8 minutes early. I can't remember that has ever happened while I've been co-chair at this working group. Luckily, we have one more session that starts at 17:40, the same room. Please bring popcorn, because we have planned for a very entertaining discussion. And see you then. Int area is in the meantime, but it's not going to be here. There's a CBOR class, I think. Thank you. The second blue sheet, if you have that, can you please bring it up to the stage? Thank you. Bring that one back up again. We might have to take